All right, so we're looking at graphing today, graphing linear equations. So for us, it's not 5.1, it's 3.1. No, look, a little bootleg doing it this way, but I already had the notes written up, so it's from another class. So math is all the same. So we'll look at graphing linear equations at 3.1 for us. And we're starting that with the Cartesian coordinate plane. All right, so we'll be graphing using the Cartesian coordinate plane. It's made up of two axes, our x-axis, which is our horizontal axis, and then our y-axis, which is our vertical axis. All right, where they intersect will be our origin. The coordinates of our origin is 0, 0. All right, to the right of our origin will be positive values. To the left of our origin, negative values. Above our origin, positive values. Below our origin, negative values. So they are broken up into quadrants, or they break it up into quadrants going counterclockwise. We have quadrant 1, 2, 3, and 4. To get into quadrant 1, you make 2 positive moves. Quadrant 2, a negative move, then a positive move. Quadrant 3, 2 negative moves, and then quadrant 4, positive, and then a negative move. We'll be graphing by what are called ordered pairs. Called ordered pairs because the order does matter. Notice it's your x move first, then your y. So that means your horizontal move first, then your vertical move. You can think about x comes before y in the alphabet, or you walk to the elevator, go down, run, then jump. As long as you remember that your horizontal move first, and then your vertical move. All right, any questions on that? All right, let's scroll up. All right, so let me erase some of this stuff so we can walk through it. Oh, didn't need to do that. So we're going to graph these 6 points. All right, there we go. So we want to graph these 6 points. Remember, if you're ever going to graph a point, you always start your origin first. So looking at 2, 5 here, you start at your origin. And because we have a positive 2, we go to the right 2. And then positive 5 means we go up 5. So we're looking at 2, 5. So that puts us in quadrant 1. The next point, -1, -3. Once again, you start your origin, go to the left 1, down 3. Right. So left 1, down 3 puts us in quadrant 3. -1, -3. All right. For -4, 2, you go back to your origin, go to the left 4, up 2. Puts us in quadrant 2. And for that fourth one, go to the right 1, down 5. And that's 1, -5. Puts us in quadrant 4. All right, questions before we look at the next 2? All right, so looking at 3, 0. So we'll go to the right 3, but then we don't move. We don't move for y because it's 0. So that actually sits on the x-axis. And then for 0, 3, we don't move left or right for the x move, but we'll go up 3. And that's actually sitting on the y-axis. All right, questions? Okay. All right, so everybody good with that before we scroll up? All right, solutions. An ordered pair is a solution of an equation if the equation is true after the ordered pair is plugged in or substituted in, whichever way you would like to say it. All right, so what would happen is that you would get this, an equation like this. They will give you an ordered pair. You will plug it in for x and y and see if it comes out to be a true statement. So in this case, they give us 1, 2 as an ordered pair. Always remember your first component is going to be x, second component is going to be y. And you plug those in accordingly. So that means 1 for x and then 2 for y. So 4 times 1 minus 3 times 2. That would be 4 minus 6. And so it's -2 equal to -2, and that is true. So that means 1, 2 is a solution of that equation. All right, any problems? Very good. All right, another key point about that, there are infinitely many solutions to a linear equation. So in other words, if I have a line that represents this equation, graph that represents this equation, every point that falls on that line is a solution for that equation. So you have infinitely many points that will fall on the line. Every point that falls on that line is a solution for your equation. All right, questions? Any questions? So just doing it one more time. This time to give us the equation of y equal to 3x minus 5. Give us 2 different ordered pairs to try to see if either one of them will be a solution for us. So on the left over here, I substituted in 2, 3. On the right, substituted in 3, 4. So we have y equal to 3x minus 5. So that means 2 will be your x, 3 will be your y. So we have 3 equal to 3 times 2 minus 5. 3 times 2 is 6. 6 minus 5 is 1. So of course 3 is not equal to 1. So that's not a solution for this equation. Then over here to the right, plugging in 3, 4. So that gives us 4 equal to 3 times 3 minus 5. 3 times 3 is 9. 9 minus 5 is 4. So 4 is equal to 4. So 3, 4, the ordered pair of 3, 4 is a solution to the equation. All right. questions? All right. Scroll up. Sorry, it's a classmate. Some evidently I don't understand why I can't get into the Zoom. All right. So sorry about that. Just trying to. I think he had the same issue last week. Not sure what's going on. So trying to help him out. So graph and linear equations. We have 3 different methods. Now for us, let me erase this right here. For us, XY chart is in 3-1. And then both of these methods are in 3-2. All right. So first method is to create XY chart. Second method is to use our intercepts in order to graph. And then third, we use our slopes to graph. All right. That's good. All right, so let's look at the first method. I'm going to erase some things so we can walk through this. All right, so our equation, y equal to 2x plus 1. We want to graph that equation. Now, to create your XY chart, you're going to choose some X values to plug in. Once again, you see the words down there, you choose them. So no real methodology to it, just choosing some simple values that you don't mind calculating or you don't mind graphing. All right. I choose -1, 0, 1. In my math lab, if I'm not mistaken, you only can graph 2 points anyway. So I'm just used to choosing 3 because, when you're doing it by hand, you always want to do is, at least 3, just in case you get one of them wrong. So we always used to do 3. I was always trained to do 3. So you choose your X values. Just remember, whatever you choose, you have to graph and you have to calculate with. If you choose 150 and then 1 million, just know that you have to graph, those points. So you want to choose something simple for yourself. So you're going to plug in X and find the corresponding Y value. So in other words, when X is -1, what is Y? All right. So that'll be 2 times -1, which is -2, plus 1. Then -2 plus 1 is -1. So just what happens in this case that when X is -1, Y is -1. All right. All right. Do the same thing for 0. Plug in 0. When X is 0. Oh, I didn't mean to write that twice. 2 times 0 is 0. And then 0 plus 1 is 1. So when X is 0, Y is 1. All right. And plug in +1. 2 times 1 plus 1. And then we have 2 plus 1. Give us 3. So when X is 1, I normally like use purple over here. All right. So when X is 1, Y is 3. So before we graph that, any questions? Any questions? All right, so graph those points. So -1, -1. So I go to the left one, down one. That's this point down here. Go back to your origin. You don't move left or right because that value is 0 for x, but then you go up 1. So that's this point right here, 0, 1. Then 1, 3. You go to the right one, up 3, and that's this point right here. Once you plot your points, you go ahead and connect the dots and make your line. All right, questions? Any questions? So, like I said, it doesn't matter what point you choose, you still will get the same line. Let's say if we chose 20, which would be way over here, it would give me a point that's up here that will still connect me to this line. Same thing as if I chose -100, which would be way over here to the left, it will give me a point that would be way down here that will still connect me to that line. So either way, you'll always get the same line. You just have to make sure, like I said, you're willing to graph whatever it is you're trying to calculate. All right. Questions? Any questions? All right. So I'm going to erase this stuff and I'll put it back, but I just want to be able to give you guys the opportunity to see the actual equation with nothing up there. All right. So we have y equal to -3/5 x plus 2. So your goal when you're talking about choosing values is to choose values that will produce a number that's not a decimal or a fraction, because you don't want to have to graph a decimal or fraction if you don't have to. So you want to put numbers in the x that will actually cancel out the fact that you have a fraction. So values like that will be values that are multiples of your denominator. So you want to choose values. It'll pop back up. You want to choose values that the denominator can divide into evenly. All right. We want to choose values that the denominator can divide into evenly. So that's what we mean by 5, 10, 15, 20, 25, 30. Our denominator is 5. We want numbers that 5 can divide into. If I had 3 over 7, then I would choose values that 7 could divide into. 7, 14, 28, 21, 70. You know, you want to choose values that 7 could divide into. If my denominator was 11, then I would choose values that 11 can divide into evenly. All right. So keeping in line with my -1, 0, and 1, I went ahead and chose -5, 0, and 5. Once again, if you want to do 5, 10, 15, you could have done that. But you just have to make sure that your denominator can divide into it evenly. So over here on the right, I plugged in -5 and just multiplied across -3 times -5 and 5 times 1. So that gave me 15 over 5 plus 2. 15 divided by 5 is 3. 3 plus 2 is 5. So when x is -5, y is +5. All right. Let's do the same thing with 0. 0 is always a good one to use because 0 will cancel out that fraction completely. 3/5 times 0 is 0. 0 plus 2 is 2. And then the last one, plugging in +5, -3/5 times 5 plus 2, so it's -15 over 5. That's -3 plus 2, which would be -1. All right, any questions?
This isn't particularly like a problem question. Are we going to have fractions the whole semester?
I don't know about the whole semester. You may see them come up every now and then.
Okay. Thank you.
No problem. I'm sorry. uh, so everybody good before we graph? All right. So you take those 3 points just like last time. You go to your origin, go to the left one. I mean left five, excuse me, up five. That's this point right here. Go to your origin. We don't go left or right because that's a 0, but then we go up 2. So that's this point right here. And then go to the right 5, down 1. And we have this point. And then you can connect your dots, which will be a line. All right, questions? Any questions? All right, problems before we go to your intercepts. All right, so let's look at the second method, which intercepts. Remember, this is in 3.2. So start of 3.2, graphing using your intercepts. All right, so your x-intercept is going to be where the graph intercepts or crosses the x-axis. Your y-intercept is going to be where the graph crosses or intercepts the y-axis. Okay. So the key to all x-intercepts is that y is always 0. Key to all y-intercepts is that x is always 0. All right, can I scroll up? All right, cool. So graphing user intercepts. Let's erase some stuff. All right, so we have 2x plus 3y equal to 12. We want to graph using our intercepts. Like I mentioned before, the key to finding your x-intercept is that y has to be equal to 0. Key to finding your x-intercepts is that x has to be equal to 0. So it doesn't matter which one you find first, you just have to hold true to that concept. So I take my equation. If I want to find my x-intercept, I plug in 0 for y. 3 times 0 is 0, and that leaves me with 2x equal to 12, because that 3 times 0 just cancels out completely. Now to solve for x, divide both sides by 2. 2's cancel, x is equal to 6. So my ordered pair here is going to be 6, 0. So x was 6, and don't forget y was 0. All right. So for our y-intercept, x has to start off being equal to 0. 2 times 0 is 0. That leaves us with just 3y equal to 12. Divide both sides by 3. 3's cancel. And be careful here. X is what was equal to 0 in this case, so that 0 comes first. And 4 is my y. So make sure we're good before we go any further. All right. Any problems before we look at the graph? All right, so from there you graph your 2 points. Your x-intercept would be 6, 0. Your y-intercept is 0, 4. Graph those 2 points. Draw your line between the two, or connecting the two. Draw your line connecting the two. And that is your graph. That's your line. Questions. All right. Let's do it one more time. Once again, let me erase this stuff. Well, I guess I don't have to erase but so much. So the same process for our x-intercept. We start off with y being equal to 0. Plug in 0 for y, so that cancels out that 4. So then that leaves us with 5x equal to 20. Divide both sides by 5. X is equal to 4. So that means my ordered pair is going to be 4, 0. And the next one, we let x be equal to 0. So plug in 0 right here for x. That cancels out 5, leaving you with negative 4y. So be careful with that. Make sure you don't lose that negative. Sometimes people do that. Don't drop the negative. So it's negative 4y equal to 20. Divide by negative 4. Y is equal to negative 5. So this would be 0, negative 5. All right, questions? Any questions? All right, so grab those 2 points. So 4, 0. I don't know if y'all can see my answer, but 4, 0. Go to the right 4, don't move off the x-axis. And then 0, negative 5, go down 5 on the y-axis. And that would be your 2 points. All right, questions on graphing using your intercepts? Let me see, are they gonna ask you guys to graph horizontal lines? It doesn't matter. You can note it. All right, so horizontal lines. Notice all of our equations up to this point had x and y in them. All right. So now, if you come down to a line and say graph, and all you have is y, then that means that y is always going to be that number. No calculation, just observation. So if you have y equal to 5, that means no matter what x is, y is always 5. So no calculation, just know that there's no other variable but y. Y is always going to be 5. So I just chose -1, 0, and 1 and got the coordinates -1, 5, 0, 5, and 1, 5. Graph those 3 points, and that will give us a horizontal line at 5. So whenever your equation is y equal to just a solid number, you will have a horizontal line, at that number. All right. Now if I have x equal to a number, that will give us a vertical line. So if you're saying x is equal to -2, that means x is always -2, no matter what y is. So I chose 1, 2, 3 for y, but x is always going to be -2, and notice it gives me a vertical line at that line. Or let's say at x equal to -2. All right, questions, any questions? All right, let's look at slopes. Still in the same section. They put intercepts and slopes in this section. So your slopes, M is going to represent your slope. So not S, but M. And it's going to be y2 minus y1 over x2 minus x1, or you can do y1 minus y2 over x1 minus x2. Just have to make sure you stay consistent. So in other words, if I do y2 first on top, then I use x2 first down bottom. Or if I do y1 first up top, I use x1 first down bottom. All right, and then rise over run, we will use as well, but we'll use that when we get to the graphing part. All right, so x1, y1, x2, y2 comes from any 2 points on the line. So I didn't mention this initially, but your slope, is exactly what it sounds like. When you talk about the slope of a mountain or the slope of a ramp, it's a numerical value that represents the incline or the slant of our lines. So we're going to have a numerical value for that, and that will be your slope. And once again, we'll be able to calculate the slope by taking any 2 points that are on the line. All right, am I okay to scroll up? All right, so first exercise dealing with slopes. They give us 2 points and tell us to find the slope. So we have -2, -4, and 3, -5. So I labeled my first point -2, -4, and my second point 3, -5. So that will be x1, y1, x2, y2. All right. So now we can plug them in accordingly. And if I'm not mistaken, yep, I did it both ways just to show you that either way, you'll get the same answer. But of course, when you're doing it on your own, you only have to do it one way. So let's do y2 minus y1 over x2 minus x1 first. So that means y2 is -5, y1 is -4. Make sure you don't lose a negative. So there's a minus sign in the formula and then we're substituting in -4. So a lot of times people lose a negative, so be careful with that. Then x2 is 3, x1 is -2. So we have -5 minus -4, 3 minus -2 down bottom. All right. So, negative to a negative turns positive. So that's why I circled those. All right. -5 plus 4 is -1, and then 3 plus 2 is 5. So our slope is -1/5. Talk about in detail as to what that means for our line in a second, but the numerical value will be -1/5. All right, so here I decided to do, y1 first and x1 first. So that means -4 minus -5 on top, -2 minus 3 on bottom. So -4 plus 5 is 1. And then down bottom, -2 minus 3 is -5. And we see that that's the same thing as -1/5 that we got initially. All right, questions? Any questions? All right, let's do it at least one more time. I want to find the slope. And then give us 5, -6, and 8, 3. Let's see what's next. Yeah. So 0.1 is 5, -6, 0.2, 8, 3. All right, y2 is 3, y1 is -6, and then x2 is 8, x1 is 5. All right, 3 minus -6, negative to negative once again turns positive, so that'll be 9. 8 minus 5 is 3. 9 divided by 3 is 3. So that'll be our answer. So notice we don't convert them to decimals or mixed numbers or anything like that. If it's a fraction, let it stay a fraction. If you simplify, you are expected to simplify. If you have 4/6, my pen not working. There we go. If we have 4/6, you are expected to simplify. So you would do that, but you don't convert to a decimal or fraction. All right. All right. So your basic behaviors of your slope. All right. Following your graph, going from left to right. If it goes up as you're going from left to right, your slope is positive. If it goes down, your slope is negative. Horizontal line, your slope is 0. And then for vertical lines, your slope is undefined. So 4 basic behaviors. Questions? Any questions? All right, let me make sure, see if you guys cover parallel lines. Yep. All right. So, parallel lines. They're lines that never touch or cross. They have the same incline, which means they have the same slope. Perpendicular lines create a 90-degree angle at their intersection, and their slopes are negative reciprocals of each other. So we'll talk about what that means in a second, but their slopes are negative reciprocals of each other. All right. So let's talk about what it means to be a negative reciprocal. Let's look at that. Well, hold on. Let me make sure everybody's good with perpendicular lines. I don't want to scroll up too fast. Everybody good? Okay. So if you're just talking about regular reciprocals, so right now we're not looking at this side over here. We're just talking about over here. If you're just talking about a regular reciprocal, what does that mean to be a reciprocal? That's just flipping your fraction. So it has nothing to do with your sign. So notice 4/5. The reciprocal of 4/5 is 5/4. The reciprocal of -10/7 is -7/10. You keep the same sign, you just flipping the fraction. And then the reciprocal of 8, 8 as a fraction is 8/1. Reciprocal of 8 is 1/8. All right, questions on that? So now what you need is a negative reciprocal, not just the reciprocal, but the negative reciprocal. So when it comes to the word negative in mathematics, that really means opposite. So you need to reciprocate the fraction and use the opposite sign. So you got to flip the fraction and use the opposite sign. So if you're talking about slopes that have, if you're talking about perpendicular lines, they have slopes that are negative reciprocal. So if my slope is 4/5, the negative reciprocal will be -5/4. You use the opposite sign and you flip the fraction. If I have -10/7, once again, use the opposite sign. So I'm going to have a positive 7/10 as my negative reciprocal. And then the negative reciprocal of 8 would be -1/8. All right. Questions on what it means to be a negative reciprocal? All right. Good with that. All right. So here, we want to give the slope of the line, a line that's parallel to it, and then a line that's perpendicular. All right. So they give us, let me do that. Okay. All right, there we go. So they give us our slope as 3/5. So if we want a line that's parallel to that, if we want a line that has a slope, if we want a line that's parallel to it, the slope has to be the same. So if you're talking about a parallel line, the slope will be 3/5. Now, if we want a line that's perpendicular to that, the slope will be -5/3. So you're going to flip the fraction and use the opposite sign. All right. Same thing with 11/9, -11/9, excuse me. If I want a line that's parallel to that line with that slope, that line will be the same, which is negative 11 over 9. Then if I want a line that's perpendicular to that, opposite sign and flip the fraction, that'll be positive 9 over 11. All right, and looks like I have one more down here. If I have 1/7 line that's parallel to it, will be 1/7. Then a line that's perpendicular to it, negative 7 over 1, which is just negative 7. All right, questions on those relationships? All right, so let's graph using our slopes. So remember I mentioned when we first started talking about slopes that we have rise over run as a part of their relationship or part of that um, information. So rise means you will go up or down. Run means you will go right or left. And so what dictates whether you go up or down versus right or left is whether you have a positive or negative number. So our positive moves will be up and right. Our negative moves will be down and left. All right. So examples right here. If I have my slope of 3/4, positive 3 over positive 4, once again, we have positive moves. So that means I'm going to go up right. I say up right. Up 3, right 4. All right. Now, if I have a negative 5 over 7, so be careful here. So sometimes people make the mistake of giving the negative to the top and bottom. But your negative is you either have a negative 5 or a positive 7 or a positive 5 over a negative 7. Remember, it can't be negative over negative because negative over negative is positive. So I always say just give the negative to the top number and then that'll always keep you safe. But if you want to give the negative to the bottom, that's fine, but you can't give it to both top and bottom. Either way, it'll give you the same incline. And that's what I was showing right here, that if I'm in the middle and I go down 5 and then right 7, that'll put me here. But if I go up 5, then left 7, that'll put me here. So either way, it'll still give me the same line. Once again, you just can't give that negative sign to both top and bottom. All right. Pretty good. All right. So what's also going to help us graph using the slope is what we call the slope intercept form. Whenever your equation is solved for y, it's simplified as much as possible. Whenever your linear equation is solved for y, it's simplified as much as possible. It's considered being in the slope intercept form. So what's sitting in front of x will be your slope. That's why that's very important. What's sitting in front of x will be your slope, and then the other number is your y-intercept, which is also very important for us. Remember, if it's your y-intercept, that means as a coordinate, your x is 0. All right. So here, just a simple example. If I have my equation solved for y already, if not, you can go ahead and solve it for y. But if once it's already solved for y, whatever is attached to x, the number in front of x, the x coefficient will be your slope. And so be careful here because sometimes people will make the slope 2/3 x. Don't forget your slope is a number, not a variable. It's just what's in front of x that is your slope, not the x. So make sure you don't include x as a part of your slope. It's just the 2/3. And then your y-intercept is the other number, which is 1. And that's what I wrote over here. Once again, just don't forget you have to solve your equation for y first. and then you'll be able to pick out what your slope is and your y-intercept. All right, one more example of that. If I have y equal to negative 18 over 13, that's 18, negative 8 over 13x minus 5, that negative 8 over 13 is your slope, and that negative 5 is your y-intercept. All right. So here will be our steps. Here are our steps for graphing using our slopes. So first thing you want to do is plot the y-intercept. Always plot the y-intercept first. Plot the y-intercept first. That's an actual point. So you want to plot the y-intercept first. Then from your y-intercept, we're going to generate another point with that slope information. So that's where a lot of people make a mistake. They go up to left, right from the origin. No, that's incorrect. You have to do that from your y-intercept, because remember, your slope is not a point, so you're not going to start from the origin with your slope. You're going to generate another point from the y-intercept with your slope information. All right. So if I have y equal to 2/3 x minus 1, the information I can extract from that, let me erase some of this stuff and we'll talk about it in a second. All right. So the information I could take from that equation is that my slope is 2/3 and my y-intercept is negative 1. All right. Now with that comes the other information. If I have a positive 2 over positive 3, that means I can go up 2, right 3 with that slope. Then my y-intercept. Remember, we already mentioned before, I keep forgetting I had that erase on, that if my y-intercept is negative 1, then as an ordered pair, it's 0, negative 1, because x is always 0 when you're talking about your y-intercept. All right, so as we mentioned before, what you're going to do is graph the y-intercept first. So you go to your origin and then go down 1, because it's 0, negative 1. So that's this point right here. Then from there, from your origin, you go up to right 3. Oh, why did it do that? Oh, well. So you go up 2 and then right 3 to get that second point. And then you can go ahead and connect your dots, which will give you a line. So once again, you always graph your y-intercept first. Then from your y-intercept, you go up to right 3 to get your second point. All right, any questions? All right, let's do it again. All right, so we have y equal to negative 1/4 x plus 3. My slope is negative 1/4. My y-intercept is 3. So that negative 1 means I go down 1, positive 4, right 3, and then your y-intercept as a coordinate is 0, 3. All right, so graph 0, 3. So you go to your origin, go up 3. Then from there, from your origin, you go down 1 to the right 4. And that's their point right there. Down 1, right 4. Once you do that, you should be able to connect your dots. All right. Questions? Any questions? Let's see. I do this one. Okay. Yeah, we can do this one too. Questions before we look at this? Look at another one. Make sure we're good. Hold on 1 second. Let's see. Yep, that's the last one. All right. Okay. So here we have an equation that's not solved for y. Your goal, though, should be to get y by itself so you can put it in slope intercept form, pick out your slope, pick out your y-intercept. So the first thing we want to do, since we're trying to get y by itself, is to get everything else over to the right side. So we'll subtract 5x from both sides. That'll give us 2y equal to negative 5x plus 8. Then from there, we want to divide both sides by 2. And so be careful here. That 2 does not just go into 8, but it has to go into the negative 5 as well. So that 2 goes into each term that's in the numerator. All right. Simplify it. That's y equal to negative 5 over 2x plus 4. All right, so we can pull out the slope and the y-intercept from that problem. Slope is going to be negative 5 over 2. Y-intercept is 4. So since that's negative 5 over positive 2, we go down 5, right 2. And that means my y-intercept, the coordinates on the y-intercept is 0, 4. All right. So as I said before, still have my eraser on. As I said before, we're going to plot that y-intercept first, then generate another point from the y-intercept. So 0, 4 is right here. Go down 5, right 2. That gives us this point right here. And that'll be our line. All right, questions? Any questions? So let's do 4 functions. Let's see how far we want to go today. Hold on 1 second. So we have 1, 2, 3. Any questions while I figure out if we want to do another section or not? Hmm. Oh, I went past the section. Sorry about that. All right, we did some of that. Yeah, we can go ahead. Yeah, that flows with this better than it flows with the next two sections. Okay. Yep, we can go ahead and do 3-3. 3-3 is short. We've done a lot of things that were already in 3-3 anyway. They kind of mixed them together. So they talked about the slope intercept form, which is what we already did here with this, slope intercept form. And I saw something else that they talked about horizontal and vertical lines. We already did that. Okay, so we just need to write the equation of lines. And I don't have to do all of this though. Okay. All right, so this is 3-3. Like I said, we've already talked about some of the things in 3-3 already. So we can just go ahead and finish off 3-3 by talking about a point slope formula. So that's going to be y1 minus y minus y1 equal to m times x minus x1. All right. So I have arrows over these three variables because these are the variables that we're actually going to substitute in for. And what I was saying by this red over here is just remember that x and y stays a part of your equation. So we're not going to get rid of x and y, and we're not going to substitute in for x and y. We're substituting in for x1, y1. So that's what we're saying down here, that my slope is m, and any point on the line will be your x1, y1 that you'll plug in. All right. All right, so we're going to write an equation of the line that has the slope of 2 and passes through the point -4, 6. So this right here is our information that we're pulling from the equation. Have our slope 2 and the line passes through the point -4, 6. So that means -4, 6 will be x1, y1. All right, so we have a point and a slope. That's why it's called a point slope formula, because that tells us to use this equation, point slope formula. If you ever have a point and slope, you can use that equation or that formula. So we plug in for y1, m, and x1. So y1 is 6, m is 2, and then x1 is this -4 right here. Once again, make sure you don't lose a negative. Distribute 2. Also, don't forget that negative to a negative right here turns positive. So y minus 6 is equal to 6 plus 8. That's the 6 plus 8. Y minus 6 is equal to 2x plus 8. And then we add 6 to both sides in order to cancel out the 6. And that leaves us with y equal to 2x plus 14. All right, questions? right. Okay, so the next one, write the equation of the line with the slope negative 2/3 and run through the point 50. So same type of deal. This is what we're pulling from the problem. M is negative 2/3. My point, the line runs through my point 50. That's going to be x1, y1. Here you go, the equation right here, or the formula, y minus y1 equal to m times x minus x1. Plug in for y1, m, and x1. And that's what we do down here. Y minus 0 equal to 2/3 times x minus 5. Distribute negative 2/3. And over here, I was just emphasizing, making sure we were cool with multiplying that fraction of 2/3 to the 5. So multiply across negative 2 times negative 5 is a positive 10. 3 times 1 is 3. And we get negative 2/3 x plus 10/3. That would be our equation. All right, questions. Scroll up, everybody good? All right, so the next one, write the equation of the line that passes through 3, 4, and 5, negative 4. So notice that in this case, we do not have a slope, but we need a slope. So we have to find our slope first. So you cannot find the line or find the equation of the line without their slope. So go back to your slope formula, your slope equation, and slope formula. Label one of your points 0.1, the other one 0.2. So the first one, 3, 4, I call x1, y1. Second one, 5, negative 4, x2, y2. All right, so that's my slope. And then here, looking at red, it says use either point for the point slope formula. So it doesn't matter whether I use x1, y1 or this x2, y2. Either one of these points will give me the same equation. Because remember, the line runs through both points, so it doesn't matter which point I use. They didn't ask you guys for standard form, so you don't have to worry about this over here. So all you would do is plug in negative 4 for m, and then choose one of these values, one of these points, I should say. I went ahead and stuck with what I already call x1, y1. So that means I'm using 4 for y1 and then 3 for x1. All right. So we distribute the negative 4. So that'd be y minus 4 equal to negative 4x plus 12. And I don't believe they asked you guys for standard form. Let me make sure I can see it though. So from here, we would just add 4 to both sides. And since I messed it up over here, I'll write it right here. Y is equal to 4x plus 16. And this should be a negative 4x, right? Left off my negative. Y is equal to negative 4x 16. one more type of problem that you guys see, and then be done with 3-3. Everybody good? All right, guess I erase this. All right, so that's the last type of problem that we'll see. So we're looking at writing the equation of the line that passes through the point 1, -1, and is parallel to y equal to 2x plus 3. So I'm going to be careful here because we want a line that's parallel to this line. So that means, like I mentioned here, you have to have the same slope. So you want to make sure you get the slope from that line. And in this case, it's going to be 2. Remember, if your equation is already solved for y, you can pick out your slope because of what is attached to your variable. What is attached to x, so what is sitting right in front of x is going to be our slope. So that lets the slope be 2. And the line that's parallel to it will have the same slope. So that means the slope we're going to use is the 2. All right. We have our point. So now we have a slope and a point. And then we plug it into the point slope form. So -1 for y1, 2 for m, and then 1 for x1. All right, go ahead and distribute that 2 and recognize that negative to negative turns positive. That'll leave us with y plus 1 equal to 2x minus 2. Then if we subtract 1 from both sides, y is equal to 2x minus 3. All right, questions? Any questions? You got one more dealing with perpendicular lines, then we should be done. Let's see. Yep. All right, so let's look at one with perpendicular lines. Erase some of this stuff. So, write the equation of the line that passes through -4, 2 and is perpendicular to 2y equal to x plus 7. All right. So just wiping everything clean so you just look at the problem. So you want to write the equation of the line that passes through -4, 2 and is perpendicular to 2y equal to x plus 7. So when we talk about being perpendicular, remember that means we need the negative reciprocal of the slope. But in order for us to know what the slope is, we have to first solve for y. So that's what I was notating here. So I took that 2y equal to x plus 7, divided both sides by 2, because remember, if you're trying to solve for y, your goal is to get y by itself. 2y was on that one side, but I need to get it 2 off of that left side. So I divided both sides by 2. Don't forget that 2 has to go into each term. So that's why I have 1/2 x plus 7 over 2. All right, so my slope is 1/2. But now I need a slope that's perpendicular to that. So that means I need to flip the fraction and use the opposite sign. So that's how I got this -2 right here. And that is the slope that's perpendicular to it, and that is going to be the slope that we are going to use. All right, so before we go any further, problems, questions, concerns. Remember, if your slope, if you need a line that's parallel, the slope has to be the same, but if you need a line that's perpendicular, you need to flip the fraction or flip the slope, and then use the opposite sign. Now that we have the slope, we can go ahead and use our point slope formula right here. Y minus y1 equal to m times x minus x1. So plug in 2 for y1, -2 for m, and then plug in -4 for x1. All right, so let's distribute and simplify. So that negative turns positive, and then we're going to distribute -2. So that's going to be -2, -2x minus 8 on that right side. All right, so then we'll subtract. Well, no, we're going to add 2 to both sides. We have y minus 2, so we'll add 2 to both sides. And then that'll give us our equation in slope intercept form. Did it again. So, yep, slope intercept form. So y is equal to -2x minus 6. All right. Questions? Any questions? Once again, I didn't see them ask for standard form, so you guys don't have to worry about that. All right. Any questions, concerns, comments? All right, so that's 3.1 through 3.3. This is a good place to stop. Next class, we'll pretty much close out chapter 3. I need to post that B4's chapter test, so I'll get that out there. I know y'all can't wait, to get to it. So my bad for not posting that. I meant to do that last week. So if you guys are good, I'm good. You have a great week. Be safe. Feel free to email me if you have any questions or concerns about anything. And I'll see you next week.
Thank you. Have a good night.
Thank you. Have a good one. See you, Wave. I see you, Wave. Take care.